All right, so this section is probably the easiest of the entire chapter 12 thing. So this should only be one video, and I'm going to go kind of quick. Why? Because you can pause. All right, so we're just going to find maxes and mins and find points of inflection where our function changes concavity. So remember, in general, if you're finding increasing, decreasing maxes and mins, that's going to be a first derivative. Set it equal to 0 and find out your test intervals. And then concavity, concave up and concave down. Just take it a step further. Take a second derivative, set it equal to 0, and then you'll find those things. So first of all, you have a parabola that's opening upward. So I know I can knock off C and D because it's not that. I also, A, have a graphing calculator, and B, I can plot that quickly because I know that my intercepts, this factors down to x minus 4, x minus 1, which means your intercepts are at 1 and 4. So it's got to be A. Okay, so I already know he's A. So now, do I have a max or a min? I will have a local, well, since it's this one, I'm going to have a minimum value. So he does not have a max. Does he have a min? Yes, he does. So I've got a minimum here. Now, why did I just kind of sort of ripped through this. I would like to know, because this is options A, B, and C. This one is options A, B, and C, and D. I don't change inflection, or I don't have a point of inflection because I don't change concavity. So how do I know that? My function is x squared minus 5x plus 4. My first derivative is 2x minus 5. And my second derivative is 2. That means he is always concave up. Okay, so I just knew just from looking at my pretty picture and from recognizing this is a parabola, there is no point of inflection because he never changes concavity. So the function has no inflection points. All right, so for number 2, I would like to find maxes, mins, points of inflection, changing concavity. So again, you've got a graphing calculator. If you need to remember how to change the window, because if you'll notice, this goes from -4, +4. So does this, so does this, so does this. And then my bottom, my y coordinates are from -100 to +100. So if you want to change your window to figure it out, just hit window. And then change your x min to a -4. Change your x max to a +4. Your scale can be 1. Because how are you moving from tick mark to tick mark? You're increasing by 1. So this is -4, -3, -2, -1, 0. This one, you're going to be increasing by 20s. So -100, -80, -60, -40, -20, 0. So when I change my y min, I'm going to go from -100 and I'm going to go to +100. My scale is going to be in 20s. Okay, and the rest of it I really don't give a rip about. So when I graph this thing, I have 4x to the third, clear, 4x to the third over minus 48x and then minus 7. So when I graph it, I should know immediately which one I am looking at. Get some of the glare off there. All right, so I know based on looking at pretty pictures, this is an option. This is not an option, okay, because it's flipped. This is not an option because it's flipped. This is a possible option. So I've got to decide if it's A or if it's D. Well, this one hits between -3 and -4, where this one hits at -4. So when I look at my drawing, this is -1, -2, -3, -4. That hits the axis between -3 and -4. So now I already know that A is my answer. So I need to figure out maxes and mins. Well, I know that this is a max. I know that this is a min. So I need to know those two values. So from a 4x to the third minus a 48x minus 7, my first derivative is 12x squared minus 48. Okay. And I'm going to go ahead and find my second derivative while I'm messing around. So this is just going to be a 24x. Okay, so when I set this one equal to 0, I can divide everything by 4, which gives me, holy cow, I can divide everything by 12. What am I thinking? All right, so that gives me an x squared minus 4 is 0. So I've got a max or a min at 2 and -2. Okay, so here's my max at -2, comma, whatever. Here's my min at +2, comma, whatever. So I could say, what are the coordinates of the relative max? My max occurs at -2, comma, and then how do you know your y coordinate? You go back to your original function and plug it in. But remember, you also already have this graphed. So I can hit calc, and I can say, would you please tell me the value, which is option 1, when x is -2. When x is -2, my value is 57. Okay. And then do I have a minimum? So my minimum is going to be, I already know he's at -2. Oh, sorry, +2. +2. All right, that's a plus. And then I can just use second calc, tell me the value when x is 2. So I get a -71. So this is a +2, -71. And now where are the coordinates of my point of inflection? So that's where it's a little bit harder to see. So this is my second derivative. Set it equal to 0. You'll find out that x is 0. So I've got a change of inflection at 0, comma, whatever. Well, if I shove a 0 into my original function, I'm going to get a -7. Or you can just go back to second calc, tell me the value when x is 0. And it's -7, which you can't really see. Okay, which means you can do the next one by itself. Trying to move on. You can do the next one by itself. Okay, and then we've got a couple where we're just going to choose which graph it is. Okay, so for part A, you don't have a function is the issue. You're just told that this is it has to meet these requirements, so we're just going to filter it down. It is continuous for all real numbers. That means there's no asymptotes, no holes. So that's true, that's true, that's true, and that's true. So that didn't help me at all. It is decreasing, or the function is dropping down, from -infinity to -1, and then again from 2 to 4. Well, if I read this one, my function is going up, so it can't be him, so you're off. If I read this one, my function's coming down. And it will stop decreasing when I get to a -1, so he's a possibility. On this one, he's going up, so that's not a possibility. On this one, he's coming down, but he ends up going up between here and here. So it must be B. Okay, so he drops down until you get to -1, and then he'll drop down again between 2 and 4. He'll be increasing from here to here and here to here, and then concave up. Well, here's your bowl. Concave down, concave up. So you can just kind of sort of wheedle it down from there. So this one, continuous and differentiable everywhere except for when x is -4. And I got an asymptote there. So that's right, that's right, that's right, that's wrong. Okay, no asymptote. He is decreasing forever. So this one ends up going up, so it's not him. Okay. This one ends up going up, so it's not him. Well, there you go. So we're done. So it's got to be C. So he's dropping down, and then he's just dropping down over time. So it's got to be that one. All right, so for this one, you don't have to do any math. You just have to interpret. And basically it's talking about as time progresses, you'll find out that you introduce something. It goes through a period of growth. Then it matures. And then it goes through a period of decline. And then there's termination. So for instance, think about a typewriter. Okay, as soon as typewriters were introduced, whenever that was, a long time ago, okay, they pretty much gained popularity a lot. But then they started dropping off in popularity because other things started doing things faster and taking its place. So the question is, the product on the left side, closest to the left-hand inflection point. So I'm going to chop this thing in half, and I'm going to ignore all this. I don't care. So on the left side of the graph, closest to the left-hand inflection point. I would like to know what point you think that is. So remember, inflection, this is going to be concave up. Okay. This is going to be concave down. So I would like to know what is closest. Now be very careful because this is not labeled well. This point belongs to email. This point belongs to smart cards. This point belongs to e-conferencing. And this point belongs to the iris-based ID card. So where does it change concavity? it looks like it's changing it right where the smart card thing is. So the product on the left side is going to be the smart card. Okay. And then what does it mean? It means that it was increasing rather rapidly, but now what is it going to start doing? It's going to start tapering off. So the rate of growth begins to decline. It's still growing, but it's not growing as fast. So the rate of growth begins to decline. And then that was your options for number 1. So don't freak out about that. I just printed all this crap off. All right. So now you can do the rest of these. You have oil pressure in a reservoir. So you're going to find maximums, maxes and mins. You can do it because it's just a cubic. You can do it by hand or you can do it on your calculator. And for number 9, your revenue in billions. You can do it by hand or you can do it in your calculator. Okay, so that is 12.6. And as always, would you please send me questions if you have them?